Alright, in this video we're going to be talking about the using statement and the IDisposable interface. Now in C#, as you probably already know, it has a managed memory model. In a language like C++, however, which doesn't have a managed memory model, you have to delete every single object that you are considered to be done with. Now that provides a very convenient place for finalization code or cleaning up things like file handles or memory or whatever you have. And in C#, however, there is no such delete keyword. You don't delete objects explicitly, therefore there's no explicit way to have finalization code. Now there is such a thing as a C# destructor called the finalizer. However, that construct is very different from the C++ finalizer. So let's go ahead and look at what IDisposable looks like and how the C# compiler expands the code for us. Now, the IDisposable interface is a sort of accepted pattern for how you're supposed to approach classes that have what are called unmanaged resources. And an unmanaged resource is any resource that is allocated by the operating system on behalf of your program and requires you to deallocate it at a specific time. So the IDisposable interface was created to sort of mark classes that need to be disposed. With a constant method called dispose. Then on top of that, the C# language itself provides a construct that allows us to conveniently call dispose at the end of a block. So let's go ahead and look at a very simple example of the using statement. So what we have here is we have three things. We have our using statement, of course. We have our variable, the variable that we're going to be using inside of this using statement, and in addition to its initializer. So the idea is that the variable that we assign inside of this, the parentheses, it has to implement IDisposable. Or if it's a dynamic type, then that check is ignored, obviously, because it's dynamic. But this can either be a class, a nullable value type, so it could be a reference type, a nullable value type, or a non-nullable value type. And it has to, at some point, implement IDisposable. Now, what happens at the end of these curlies is very interesting. The C# compiler is actually going to emit out code that explicitly calls the dispose method on the variable that we initialized and declared inside of the parentheses. So to look at the sort of breakdown about what the C# compiler emits when it sees this code, we first open up an anonymous block. We then create our variable, or our resource is what it's referred to as. We then open up a try statement, or a try block, and a finally block. Inside of our try block, we put our statement. So these two comments correspond to the same code. If I were to put any code inside of here, that's where the code would be once the using statement is expanded. Inside of the finally, if this is a reference type or a dynamic type, what we're going to be doing is the C# compiler is going to make sure that our variable is not null, our resource is not null, sorry. Then it's going to cast it to the IDisposable interface and invoke the dispose method on it. Now, it's actually significant that we do this casting here, particularly in the case of explicit interface implementation, and just refer to that video if you don't know what that means. But this cast is significant. So basically, this is the entirety of what a using statement gets emitted to as. The only other interesting thing about it, besides the fact that our finally is going to be guaranteed to be executed no matter what happens inside of our try statement. So once execution leaves our try statement, it will always go to the finally statement, whether or not there is an exception, a return, a yield, a break, a continue, whichever. But the other interesting thing is this anonymous block. And that's significant because it disallows access to our resource outside of the using statement. And, well, I mean, obviously that's important because we wouldn't want to be able to access a disposed resource. So there are a few interesting things you can do with using statements. You can initialize multiple resources inside of the parentheses. Of course, because you're using multiple variable initialization syntax, you cannot use implicit typing. So if we were to do streamwriter sw1 equals new streamwriter out1.txt, comma, sw2 equals new streamwriter out2.txt, this using statement is valid and is actually equivalent to as if we had written two using statements. So what I mean is if we were to write a using statement right here, and another one immediately following, we would essentially get the same code. So you see that when we do use multiple variable initialization syntax, we are creating multiple levels of try and multiple levels of finally and so on. And this works obviously because the using statement, much like the if statement, for each statement, while statement, and so on, allows you to omit the curly braces if you are only having a single line in the following block. Other than that, the only other weird thing you can do with using statements is you don't actually necessarily need to define a variable. I could do this. Why would you do this? Well, no idea. Basically, you can't access this object at all inside of this block. Some people actually use this syntax in interesting abuses of the C# language, where they do things like using new suppress errors, and then inside of the block they do stuff, and then their suppress errors class has a special constructor that does a bunch of weird stuff, and then its dispose method undoes all that weird stuff. This use is commonly discouraged. The idea of a using statement is explicitly for unmanaged resources, and if you were to use it for anything else, you might confuse developers who are reading your code. Other than that, there's really no other considerations of the using statement. That's about it.
Okay, well with that, that's going to wrap up this video. Thanks a lot.